So in our today's class, we'll try to see the details of digital image processing and analysis. Up to now, we tried to introduce about image digitization, image compression to save memory space in the bandwidth for transmission. Now we need digital image processing basically for designing a system that can be able to recognize, to identify, or to verify a given object. So towards designing a digital image processing systems that can able to recognize a given object, or that can able to identify one object from another object based on the characteristic of the object itself, we need digital image processing and analysis. So when we are looking to the detail of digital image processing, there are three levels: the low level process, the middle level process, and the high level process. The low level process is a major part, especially in image processing, because first of all, we have to make sure that the digital image that we are capturing, digitizing, and compressing should fulfill the quality and the naturalness that we are expecting. So to make whatever system that we are designing as effective as possible, that can satisfy the user's requirement, we have to first of all make sure whether the image is with good quality and the naturalness. Towards that, image processing is critical, which is a low level. The input that we are submitting for the low level is the image itself, and the output that we are expecting is the image. The difference is the input that we are submitting for the image processing step is maybe with noise, which requires restoration of the original quality, or image enhancement, which requires optimizing the quality of the image. But during digital image processing, sometimes rather than dealing with the color as it is, because we have infinite color, which requires color modeling, it's better to move to convert from color image to grayscale image, from grayscale to binary image, to simplify the process. That's called binarization. Binarization is the process of converting the grayscale image with 256 colors to 2 colors. That's why it's called binarization. So we are converting the grayscale into monochrome image, black and white image. Then skew detection is also another thing. Sometimes the image that we are capturing using our cameras or scanners or whatever media that we are using for capturing, there may be tilts or skewness, which needs to be corrected to the normal position. Correcting and requires skew detection and the correction. We have to understand the angle of skewness, and then based on that angle, we have to correct the skewness. That will make the system to easily recognize the object. Image restoration and enhancement are the basic steps, because whenever we capture an image, obviously we are expecting noise. The noise that comes from the external environment, or the noise that is available within the original content itself. Or else also when we are transmitting from one media to another media, there are possibilities for the noise to affect the image. So always before applying any application using digital image processing, we have to make sure that the image is with good quality, naturalness, using image restoration and image enhancement. There are many image filtering techniques as per our requirements through experimentation, we have to identify the filtering technique that works better, either in frequency domain or spatial domain. Then once we make sure the image is with good quality, free from skewness, within the normal image size, then we have to go to the next step, which is called image analysis. Now taking the natural and quality image produced by image processing or pre-processing, we have to apply image analysis for extracting a representation for image, because image is not directly manipulated. We have to extract the characteristic, the features, the representations which are available within the image itself, which is called mostly content-based design. So we are understanding the pixels that are distributed within the image. But before extracting the feature, we have to first of all segment the image into its constant parts. Like maybe there is only one picture within the image, but that one picture should be identified from background, because in any image there are at least background and foreground. The foreground is a picture, the background is a space where the picture is available or the foreground is available. Partitioning the two at least is required. Or in other images, there may be multiple objects available. If you are dealing with a document image, there are characters, there are words, there are sentences, there are paragraphs, or there are phrases. Sightings should be extracted. Whenever, for whatever applications that we need. If you go for optical character recognition, whether it's handwritten, printed, or typewritten, or fax written, or braille, we need to identify the characters, because every character should be recognized independently to form a word. But if you go for designing a retrieval system or a search engine that can identify, as per the user's query, relevant documents in the form of image, rather than dealing at character level, we have to deal at word level. So that means, depending on the application, we have to identify the unit of that document, whether it's character or word or phrase in the case of document image. But we need document image, digital image processing for different purposes. Our documents are not only textual documents. We have figures, we have pictures. Maybe I want to design a face recognizer. Maybe I want to design a signature recognizer, or I want to apply digital image processing for medical or for quality crops identification, like sorghum, maybe wheat, coffee. There are many quality and grading required when you go to different seeds and crops. So towards that, we need to define our unit of recognition or unit of identification. Then accordingly, we have to apply image segmentation. Image segmentation is the first step in image analysis, and it gives us the subparts of a given image as per our requirement. Once we identify the region that we need to recognize or identify or verify, then that segmented image should be represented, because we can't directly manipulate like textual document. In a textual document, you can access characters, words, phrases as per your requirement. But in image, that's not possible. So we are accessing not directly, indirectly, through feature extraction or by describing the image. How can we describe image? Image is basically a combination of pixels, and the pixels are telling us intensities, and the combination of pixels gives us luminance. Then we can detect texture, we can detect size, shape. The basic thing is the color of the image. That is the feature extraction for representing the image. Maybe sometimes if the extracted features are too much, we can go for feature selection also. Or from the beginning itself, we have to define what kind of features we need rather than extracting all the features that are available on the image. That means feature selection. Then once we extract the feature, we represented our image, then we can go for different tasks. But before applying any task, we have to apply the machine learning algorithms like classification, clustering, or supervised machine learning, unsupervised machine learning, or semi-supervised machine learning to make the system learn based on the features and create model. Then that model is used for image understanding. Image understanding is at a higher level, which is also called computer vision. Making the computer visualize the image or the object. Visualizing means making the computer system see the image, like how human beings are visualizing and the scene, such that it can say, this object means this as per our application. So the higher level image understanding is the level where, based on the features extracted, making sense of a given object as per our requirement, whether it is verification, identification, or recognition. Then as per our requirement, we can design the system. Verification is a one-to-one comparison. If you go to bank, before you ask for cash, the bank cashier has to check whether you are the person who is asking for the cash or not from your book. So then they are checking whether the book is yours or not. To check whether the book is yours or not, they are checking your signature against the signatures available in your database. So rather than the person is expected to sign, we can automatically recognize your signature and compare it with the signature available. So rather than manually comparing one's signature against the database, the signatures available in the database, we can do it automatically recognizing. Or else maybe sometimes even no need of signing. Fingerprint is one of the unique characteristic identifier of every individual. So then through fingerprint also possible to design a system that can verify whether the book account is the person's book account or not. Or else maybe sometimes you lost your book account. In such a case, identification is critical. Identification means one-to-many comparison. While verification is one-to-one comparison, identification is one-to-many comparison. A list of objects are available in our database. Given one object, we are making sure that one of that object is similar with one of the objects available within our database. Then whichever is near to the object that we are checking, we can compare the two. For search engine design, we need it. For information retrieval systems, such identification mechanisms are critical using similarity or dissimilarity measurements. So digital image pre-processing is the first step, which is trying to make the image that we captured digitized and compressed, whether it is with good quality and naturalness or not, through different image filtering techniques It is trying to make sure whether the object is free from noise or not. Also, if there is a skewness, it's trying to deskew whatever is available in that image. If it requires normalization, reducing the size or increasing the size, again, it's a pre-processing task. Then finally, converting color image into grayscale image to monochrome or binary image is another task. Once the image is prepared, says that it's ready for designing the application, the next step is image analysis. So basically, image processing is making ready the image for whatever application we need it. So it is a kind of data preparation. Then during image analysis, we are trying to identify the object that we want to deal with and represent that object using its characteristic or features as a representation for designing the system, to identify, to verify, or to recognize. So image analysis is dependent on image processing. If image processing is done effectively, efficiently, then the image analysis is also performing better. Because during image analysis, we are trying to identify the object which exists within a given image. Maybe there are multiple images within the image, or maybe we want to separate the background from the foreground. If the image is clean with a better quality and naturalness, segmentation and the feature extractions becomes more easier and effective. And again, image analysis is the base for image understanding or computer vision, because the computer vision is dependent on the representation of the image, which is called feature extraction. Feature extraction is representing every image using numerical values, because in any image there are numerical values as a representation of every pixel, depending on their intensity level. In a binary image, there are two intensity levels, 0 and 1. In a grayscale image, there are 256 intensity levels, starting from 0 up to 255. In color image, there are infinite intensity levels, but they are represented by color modeling like RGB for their representation. So there are 3 levels for representing every pixel. So based on the feature extracted and the model created by applying machine learning algorithms, then we can go for image understanding, which is also called computer vision, making the computer visualize the object. That means enabling the computer to see the object. When the computing system starts looking at the object, it starts identifying the object, it starts understanding the object. So that it starts differentiating the different objects that it is attempting to visualize, based on which we can design different systems. The first assignment is also to review about the different systems that are possible to design using digital image processing. We can use it for securing our information systems or our buildings. We can use enhanced domain for checking automatically whether the image is positive or negative, or the existence of cancer or not, or brain tumor or not. As per our requirement, we can use digital image processing for applying it in medical areas, for medical image analysis. Says that we can identify breast cancer. Says that we can identify brain tumor. Says that we can use it for identifying whether a person is positive or negative for a given case. We can use also, especially in our countries, for agricultural products, to make sure that the product is with a better quality or not. We can apply it to check the quality of coffee. the quality of the different seeds that we have, using the leaves, using the seed, using even we can identify the soil, and then we can detect which soil is better for which kind of seeds. So as per the soil type, we can classify which soil is suitable for which kind of agricultural products. So depending on the situation, we can apply digital image processing to make things that are done by the human being easily done by the computing system, especially the visual part. Most of the things are done by human beings using our visual sense organs. Since we are nowadays capturing videos, images using our cameras, camcorders, scanners, then we can use digital image processing for recognizing, verifying, identifying whatever we need to identify or verify or recognize. Plus, optical character recognition is another application, because nowadays we have to convert whatever textual documents that we have, especially those historic documents. Maybe they are written using type written ones, or computer printed ones, or handwritten ones, or brain written ones, or even sign language written ones. So I think it should be finally easily available for the users, because they are containing not only information but also knowledge. How can we archive historical documents? The first thing is we have to check their quality. Sometimes we need to apply image enhancement, even if the original document is poor quality, making the quality up to the expectation of human is possible using image enhancement. So to digitize all the document, whether they are textual or picture, we need digital image processing again. So one of the applications is optical character recognition, which is trying to recognize typewritten one, handwritten one, or computer printed ones, or braille written ones, because those eye visions are using braille, and within the braille there are a lot of information and knowledge. We have to recognize that braille and convert it into textual form. Even nowadays, those things are used for speech recognition. So image understanding, image analysis are the basis for many applications. That is the computer vision stage, which is trying to visualize the image or the video, which is mostly a combination of image, and then making it applicable for whatever human needs to apply. So there are three levels in image processing. The lower level is the most critical one. We have to make sure that the images with good quality ready for image analysis and image understanding. We already discussed the acquisition, the digitization, and the compression part. But still, those processes are not 100% accurate. There are many defects available because they are an approximation. So enhancement and the restoration of images are critical. Normalization and the skew detections are again critical. Then after image pre-processing, we have to also analyze the image. We have to identify the sub-pictures within the image, the sub-image within the image, or at least the foreground should be, the background should be identified from the foreground, based on which we can concentrate in our future extraction, just identifying only the characteristic of the picture ignoring all other parts, then we can go for pattern matching or machine learning classification and the clustering. Then which are the bases for high-level image-based application design, like face recognizer, like signature recognizer, fingerprint recognizer, content-based image retrieval, optical character recognizer, biometric analysis. So in general, these are the major steps in image processing. In any image processing, the first step is defining the problem. Whether you are doing project or research, the first step is the problem. So in that given domain, we have to define the problem. A problem is nothing but the difference between what's expected and what's going on actually. So whenever there are differences, obviously we have to advance forward by defining problems, gaps, as compared to the other world. Then we have to start collecting image. If there is a collection of image in our databases, data warehouses, we can use that one, but still we have to update it. To update, we need to acquire the image. When we are acquiring the image, we are using our cameras, digital cameras, scanners. But before using the camera and the digital scanner, we have to define what is the dot per inch we have to use, because the resolution of the image is dependent on the dot per inch that we are using. Dot per inch is defining the image size. How many pixel by pixel image we are capturing. For a good quality image capturing, how much DPI or dot per inch we have to use depends on for what purpose we need that image. If you need the image for historic purpose, or if you need the image for frequently reprinting purpose, or if you need the image for uploading over the internet, or if you need the image for designing an application, still the dot per inch that we have to use is different. So the dot per inch that we are using is dependent on for what purpose we need. So that means we have to define the problem, and then as per the problem, we have to start capturing the image. For optical character recognition, for document image retrieval, 300 dpi is enough. But for image recognition, face recognition, signature recognition, we have to go up to 600 dpi. For image which is reprinted frequently, it has to go up to 1200 dpi. So that means for getting a better quality image, increasing the number of dot per inch is better. But the problem is, as the dot per inch, as the number of pixels appearing in a given image increases, the quality, naturalness of the image increases. But the problem is what? The space requirements of the image also increases. So when we are acquiring the image, we have to think about the digitization procedure, sampling, quantization, and the compression, especially the compression part, because any image acquisition tools, if it is digital, it's passing through the sampling and the quantization. It has to identify samples as a representation for all pixels in a given image, and then it has to define the bit depth for the image depending on the digital image type. For black and white monochrome image, 1 pixel is enough. For or 1 bit is enough. For grayscale image, we have to use 8 bit. Since in a binary image there are 2 colors, but in a grayscale image there are 2, 5, 6 colors. And again for color image we need 24 bits as a representation of the combination of the RGB red, green, blue color models. But as the number of pixel dot per inch increases, the memory space requirements of the image increases, even if we are getting a better quality image. So we have to apply compression techniques. Nowadays we have a big data that we are capturing, that we are getting from others, that we are downloading from the internet. As a result, compression is a must. But when you are compressing, can we go for lossless compression or lossy compression? We have to think. Especially the lossy compression is good for image that we are uploading over the internet. Because as we are uploading more image, since it requires more space, by applying lossy compression techniques, since users are not missing the quality and the naturalness of the image, we are saving as much space as possible to upload as many images as possible. But if you need it for application design, face recognition, signature recognition, content-based image retrieval or document image retrieval, or optical character recognition, it's better to go for lossless image compression. Without losing any content, the image has to be compressed. So later on, when we are trying to design the system, since all the details within the image are available, we can easily represent the image. So PNG, TIFF, PNM are the best solution for capturing the image, for using the image in any application design. But for uploading, the well-known JPG or JPEG, which is designed based on losing. GIF is also another option if you are capturing an animated image. Then once the image is acquired, digitized and compressed, since during compression, during digitization, sampling and quantization, some quality is lost, some naturalness is lost internally before using it for any application, or maybe even noises are coming to the image when we are uploading from the internet, or when the data is transmitted, the image may lose its quality. As a result, image enhancement and image restorations are a must. Image enhancement is required if the original image by itself is with poor quality, especially for historical pictures, images, documents. Historical documents through time, they are losing the content. So when you are capturing the image from those original documents or pictures, the artifacts internally may be lost. We may be unable to read the content of the historical document, textual document. As a result, we have to recover back the original document. So we have to recover back the original quality and the naturalness. Even if the original image was poor quality, using image enhancement, there is a possibility to recover back. And it is also one of the research topics nowadays. Especially since nowadays digitization is required everywhere. The other task is image restoration, which is the opposite of image enhancement. Image enhancement is trying to enhance the quality, naturalness of the original content. But image restoration, the given content may be with good quality, with good naturalness. But while we are capturing the image, or while we are downloading the image from the internet, because of different reasons. Maybe the image is degraded. Maybe noises are affecting the quality, naturalness of the image. So that noises which are degrading our image should be removed. If removing is not possible, should be reduced. So filtering techniques are critical for image restoration and image enhancement. And as there are many filtering techniques, depending on the domain that we are dealing with. But after image restoration and image enhancement, even the restoration and the enhancement itself is an approximation. Because we are not 100% sure that the image is enhanced, the image restored, while enhancing and restoring the image. Maybe we are adding more noises into the image, especially at the border areas of the image. Structural change may be happening, shape change may be happening. For that, we need morphological processing. Morphological processing is a process of making sure that the structure is correctly preserved or not. So whenever something is wrong within the structure, morphological processing able to recover the structure of the image. So this is mostly applicable in a binary image, but it's also possible to apply it in a grayscale image. You'll see the techniques how to apply, because there are dilution, erosion techniques available, which are trying to dilute if there are missing pixels. There are steps to erode if there are extra pixels added. So both image enhancement, image restoration, morphological processing are the techniques which are frequently used during image pre-processing. After image pre-processing, the next step is image analysis. So again, during image analysis, there are different steps like segmentation, feature extraction, classification.